Hey everybody, welcome to the series on KCNA Prep. Today we'll be doing the Kubernetes Fundamentals, and I'm very happy and excited to meet for the first time Wally Chadi. So Wally, could you please introduce yourself?
Hi everyone. Thank you, Brad, for having me, and thanks everybody joining. My name is Walid Chari. I'm a platform engineer and certified KA, KCNA, CK80, the whole quadrifactor, and basically have some other system and security administration certifications. I'm quite passionate about the cloud native community, and anybody joining the cloud native community will understand why. And thanks for Brad for giving us this opportunity to cover one of the new certificates, the KCNA.
Yeah, thank you so much for coming. So yeah, for those that don't know too much about the KCNA, it's sort of, I guess, the entry level certification that we have for the Kubernetes and the Cloud Native Associate. So it generally consists of, basic Kubernetes fundamentals and really the whole cloud native ecosystem, from, how the CNCF works, the governance, a little bit on, SRE, on observability, GitOps, a little bit of service mesh, and just general sort of cloud native stuff. So, and if there's anyone here that has any questions, please let us know and ask as you go. It's really good to see that we have a lot of people here already. And yeah, so Walid, what do you reckon we start off by going over a little bit about the exam and what's involved?
Let me share my screen. I have some tabs open.
Sure.
Well,
Awesome.
Me and Brad agreed that we will do this like an informal. This is the first session, so we would like to hear your feedback. We saved the best for the last, by the way. Next week we have Muhammad Abu Bakr, and he have a great report to share with you. But let's see the screen. So I start. This is Brad, actually. He was one of the early beta testers, and he wrote a blog. This is a very highly recommended blog to read, because he was exposed to almost the whole question bank.
The whole questions, yeah. It was 120 questions.
120 or 200? I forgot now.
I think it was a lot. Yeah, it was a lot.
And yes, and basically they keep fixing the questions, adding new questions. So and that's good. Okay, so this is one of the entry points. For news, we usually start meetups and stuff like this with news. There is actually there is actually a discount. If anybody didn't buy it yet or considering buying it, you have until 3 days, until the 25th, I believe, with this promotion. Okay, and you can get a discount on the course and the certification. The course is not enough, but it should cover. You will see in the blog of Brad, there is a course from edX for free that I guess covers some of the course. That is this is my LinkedIn, by the way, that covers the essentials. Okay. Okay, and the other news actually that I really like, yesterday, Honeybot, which is like outsourcing recruiting, but they do some videos on open source technologies. They released the first part of the Kubernetes documentary, where the people did. Yeah, so you find Joe Beda, you find from the CNCF, and the people that nobody considered them as the founders, but they are the founders, like part of the original team, like Vele, which was one of the 5, he and Tim Hawken. But when we always talk about Kubernetes founder, we talk about Joe Beda and Brendan, but we forget Tim Hawken and Vele. So this is good news also. GitHub, yes. What do you think? Did you watch it?
Good. Yeah, I was lucky enough to go to the private screening, so I've actually seen the part 2 as well. So
all right.
part 2 was really, really awesome too. So this is almost should be like a must for the KCNA exam as well, just to really see the history and how it's evolved. Like, yeah, I highly recommend this documentary as well.
Yes.
Very
And the good
interesting.
news that Cloud Native Foundation are considering this type of documentaries for other projects. So they will be doing other projects, and we hope to see these soon. So that's the news I have. Other than that, I mean, 123 and the deprecation of Docker is all over the place, and you can read about it. Uh, Now, I created. This is Muhammad Abu Bakr. He's going to be here next week. I haven't checked his repo yet, but I believe it's good. Everybody is referencing it, and I know Muhammad. He's one of the AWS community builders, specialized in containers, EKS, ACS, and containers in general, and he's like a DevOps consultant. So I know that he produces good quality content.
His repo is very, very good. I went over it a while ago
All right,
and
good. Yes.
was very impressed. Yeah.
Okay. I was trying to do a repo, and he was actually one of the contributors, and I updated it just a little bit today, because if we talk about the Kubernetes and Cloud Native Associate Certificate, unlike the other certificate, it's meant to be for everyone. The other certificate were like they had a different persona in mind. The CKA had the administrator, the operator in mind. So it's certified Kubernetes administrator. It's good for people that are managing or architecting the platform. They want to understand how things work and how things integrate with each other, and be comfortable with troubleshooting, and be comfortable with the architecture component and the how they interact and configured and stuff like this. The CKS, which is dependent on the CKA, is more like the next level of the CKA. It's more about security. Now you have a cluster, how you want to go to production. So how you want to secure the configuration, how you want to secure the workloads and stuff like that. The CKAD is like for the general Kubernetes user, for the developers. Now you have an application, how you want to run it, what kind of pattern you want to run it, how you want to scale it. Do you want to have it as replicated, resilient, things like that. But when we see the Kubernetes and Cloud Native Associate, this is the latest certificate from Linux Foundation, and it's based on feedback from the community. It fills the gap for other people involved with Kubernetes, but are not engineers or not technical, like product managers, sales, anybody around Kubernetes or anybody around Cloud Native that would like to have a roadmap or have a way to qualify his skill, or basically to see where he or she or they stand on the knowledge scale of Kubernetes and Cloud Native. Now, the challenge when it comes to Kubernetes and Cloud Native, Kubernetes is not easy, and Cloud Native is quite wide. I mean, everybody knows the landscape of the Cloud Native. So the challenge in creating this certificate is the depth, is not the depth. So it has to be more breadth than depth. But how can it satisfy and fulfill the requirements of the Linux Foundation of the CNCF, in being like a benchmark, and hiring managers and companies can use it to validate the skills of the people that are certified using this certification. So the certification itself is not really that difficult, and one key takeaway that you need to take from this is that there is lots of material for introductory Kubernetes, for containers, for the cloud native. You don't need to delve that deep. My opinion, if you delve deep, that's fine, and that's good for you, especially if you are taking this as a career. But just to pass the certificate, you need to basically, it's more about breadth, it's more about definitions, it's more about knowing the standard, knowing what exists out there. Okay, the exam is 1.5 hours, and it's more than enough, especially if you have been working with Kubernetes and you have been following the cloud native. It's more than enough. The passing score is a little bit higher than the others. It's 75%. The certification validity is 3 years. And as we said, there is no prerequisite. The only prerequisite is that you have passion, you have curiosity, and you would like to pursue this kind of certificate. The cost is $250, but as we have seen, there are always discounts because of events, because of holidays. So try always to find a discount before you buy it. Okay. Now, quick preps. It's about Kubernetes and cloud native. And Kubernetes, when you look at the exam site, and what kind of domains it examines you, you'll find it covers 5 domains. The fundamentals, and it's 46%. It's like 46% of the exam on Kubernetes fundamentals. Because cloud native, if you think about it, it centralizes around Kubernetes, and Kubernetes basically used containers. Especially if you see the documentary, you will understand what I'm saying. I mean, without Docker, Kubernetes didn't exist. And now without standards, without the community, basically the cloud native wouldn't exist. So the most major part of this is the Kubernetes fundamental, and then the container orchestration. So covering Kubernetes and covering container orchestration, you are nearly there, okay? And then you cover the cloud native architecture. This gives you a passing score if you just want to pass. But this is not about passing. This is about learning. This is about your journey to the cloud native and Kubernetes world. So the most important thing after you're having a cluster up and running and you understand the architecture and you can deploy application is how to monitor it, how to make it reliable, how to maintain it. So observability is there. And then how about delivery? How can you guarantee that you are following the cloud native principles and best practices, and how you package your applications? So application delivery fundamentals, GitOps, CI/CD is there. And I love this certification. The way it was the curriculum, the way it was chosen, and the domains that they were chosen. I mean, I think they are perfect, and they are a good entry point for anybody, even interested on the other certification, on the CKA and CKAD and stuff like this. What do you think, Fran?
Yeah, no, I think it was really good. Even I learned something when I did it as well. I got to learn, there was pieces here and there that I studied for as well, and I still learned. So, yeah, I think it's really good. And yeah, I like what you said about wait to buy the exam as well, because yeah, you're right, there is always discounts, particularly around KubeCon. If you buy early bird ticket to KubeCon for $10, you generally, and don't quote me, but every time I've been there, they've given you 50% off the voucher. So that's a steal really for getting the exam. Don't rush into buying it. And it is good to do a introduction to Kubernetes as well, because that you can see that takes up a big percentage. So you do really need to know, to start understanding the core components as well. And Walid, we have a question already. So this is from Annalisa. So I'd like to understand which is the effort to prep the exam and if there's a comprehensive course to attend. So EDX or Linux Foundation specific courses.
Okay, hi Annalisa. So there is a course that is by Linux Foundation. It's called the Linux Foundation 250, I believe. Linux and Kubernetes. Is it just a second? I have it in my repo.
Yeah, it's relatively new. I think it came out maybe a month ago. Is that the one we're talking about?
Yes. So there is, okay, so I have a repo that I'm trying to capture which courses and which repos that are out there. So there is a Udemy practice questions, and you just qualified for one. We have 2 more, and basically who asks the good questions, we'll give them the 2 more. Brad will select the other 2. So Annalisa, contact us after this. I'll give you the voucher for a course by Andrew Brown. He's an AWS community hero, and he's preparing a course. He runs a website called ExamPro, where basically he have like helping material like cheat sheets, flashcards and practice exams and the course that will cover the KCNA in more depth. Udemy, it's it's Andrew Brown and other 4 people from the cloud native and from the cloud basically community that have worked together to create 2 sets of practice exams. And they cover really a lot. They do cover a lot. The Linux Foundation course, Linux FS 250, I hear 2 feedbacks already. It's not enough, but it's good. It's good to get you started. And the one that Brad mentions in his blog, I think it's quite similar to this. I think it's the same, but it's the free one.
Another one I was going to say that I really recommend as well is Code Cloud. So Munsha Banambeth, I believe they have a free introduction to Kubernetes. He explains things very well with graphics. So Code Cloud's another cool one to check out.
Yes. So Code Cloud, they have introduction to Kubernetes. They have introduction to Docker. They are these introductions are part of the freecodecamp.org. Freecodecamp.org have lots of good courses, coding and development ecosystem and infrastructure also related stuff. There is the VMware Cube Academy and there is the Civo Cates Academy, but sometimes they are a bit deeper in some subjects than the depth you need. You don't need really deep. You need just basically light and more exposures. What I think there is for quick preps, there is Nana. I put the course here.
That's a good one too. Yeah.
Yeah. Really so Nana collaborated with another YouTuber, Amigo Code, which produces quality technical content, and they presented Docker and Kubernetes in 4 hours. So this is like a 4 hours course that will teach you basically the basics of Docker and the things that you need Docker or containers, because basically we're not really specific to Docker, where Kubernetes can use any container runtime, but the most popular runtime happened to be Docker, and the container runtime that Kubernetes started with happened to be Docker. So this course is 4 hours, and it's one of the good courses that I love. Especially it's a collaboration between 2 container heroes here.
So, and I guess just quickly on that, we talk about how Docker was the first runtime. What I found interesting studying about this exam was the open standards and the interfaces. So the CSI, the CRI, all those, a little bit of the history back of how they've developed it as well. I think watching YouTube videos of Kate Jumanji and her blog on Medium as well, that was really fascinating stuff to learn a little bit more about that and just see the little bit behind that as well. It was really cool.
Yes. So as Brad said, the course is about open standard, and there is lots about container technology. I mean, it's not just Kubernetes. So you need to know about container runtimes, CRI-O, Docker, Containerd, how they differ, where do they meet, what's the special use cases. I mean, the course, if you ask me, go over the concepts and go over the definitions, the glossary, and whatever term, like if I say CRI-O, you know exactly what I mean by CRI-O. Okay, it's a container runtime. It's minimal. It's not as bloated as Docker. And that's why we had Docker shim and stuff like this. And what is Containerd? What's the difference between CRI-O and Containerd? What is OCI, the Open Container Initiative Standard? What is CSI, the Container Storage Initiative? What is CNI, the Container Network Interface? What's CRI, the Container Runtime Interface? How do you integrate with the Kubernetes? Why they were used? What's the use case of them? What's the definition? That's all what you need. You need basically what's the standard or what's the terminology and what kind of definition. And if you know about 1 or 2 use cases that makes it different from other alternatives, that would be good. Let me give you an example. If we talk about service mesh, which is part of the it's part of the container orchestration also here. So how do you define the service mesh? What is the special features of service mesh? What are the service mesh technology or tools available as part of the CNCF? For example, STU is not part of CNCF, but you can still consider it. And what's the difference between STU and Linkerd? And so on and so on. Storage, the same thing. Yeah. So I hope
guess
we
you
answered.
you could also go to the CNCF landscape, and under the categories as well, you could just do a little. You click on them and just see the basic definitions and say, well, this is what Argo CD does. This is what Flux does, and that's generally what you need to know about GitOps. What use cases do they have, etc. as well. Yeah.
Yes.
Yeah.
So the CNCF landscape is huge.
It's
Okay,
massive.
you don't need to, it's massive. You don't need to know everything about it. Okay, but for example, if we take, let's take service discovery here. So etcd. So etcd is actually a core component. It's part of the control plane of your Kubernetes cluster, and it's a there is only a single distribution that has replaced etcd with MySQL and a shim for etcd, that's Rancher, to get better scalability and better performance and to get even Kubernetes at the edge. So they had a special use case for that. Okay, but so what does etcd fits in the Linux, in the CNCF and Linux Foundation? So you can see here it's a graduated project. And what does it mean, graduated project versus sandbox versus incubated? I'm guessing after basically you prepare for this exam or this certification, and after you prepare, that you at least know the difference. You know what CNCF stands for. What is Cloud Native Computing Foundation? So it's an organization that many organizations and many individuals partner to, and they are competitors, but they work with each other, they collaborate with each other to produce an open source ecosystem for application delivery. And this covers lots of stuff. It covers storage, it covers container runtimes, it covers networking. We were talking about the container runtime. If you look at the container runtime, we'll see Containerd, we'll see CRI-O, we'll see Firecracker from AWS, a very specific use case. We see gvisor from Google. So basically, you see AWS and Google in the same neighbors, and they are quite competing with each other in the cloud space. But when it comes to CNCF, they are collaborating with each other. Containerd, the same. IBM is a big contributor, and CRI-O is Red Hat, which is part of IBM now. But they all collaborate together, and you'll find developers from each other. Singularity, which is like an HPC container, and you find others. So what is it? And you might expect a question like, I have LXD versus CRI-O versus Containerd. Which one should I select? So based on the use case of the question, you know that LXD is like a system container, while Containerd and CRI-O are application container. Firecracker is like virtualization. gvisor is like for security. So if you know the use cases behind them, Rocket deprecated, but it was part of the specs that OCI considered in the beginning. And you don't see Docker here because basically Docker, the container runtime actually is Containerd. It's modular now, and the Containerd runs another low-level runtime, which is runc. And you don't see runc here because it's very specific. So knowing the definitions, know basically what is Containerd. It is a container runtime and stuff like this. That's what matters for this exam.
Yeah, and I guess it would be fair to say that only look at incubated or sort of the onboarding projects as well. You don't have to study like 400 or whatever crazy amount. Just focus on the highlighted boxes, and generally that will get you through.
Yes, and Sayam is another very active CNCF ambassador. He created, and he is asking actually in Twitter, what else can I add here? So he created, these are the CNCF minutes, like he takes a technology and explains it in 5 minutes. So Flux is part of the exam. Flux CD is a GitOps tool. and there is Argo CD. He didn't cover Argo CD, I think. He didn't. But he covered lots of the things that will come in the exam, like Flux, like Fileco, Containerd, Helm for the package management, for the application delivery, Linkerd for the service mesh, KDA for the scheduling. So scheduling is a big part of the exam. Prometheus for monitoring, Kvarno for the governance, K3S, which is a Kubernetes distribution used specifically for edge use cases. And he have Captain, Longhorn, Storage, Harbor, Registry, Thanos, part of the, if you want to scale Prometheus, and OBA, which is part of the exam, also part of the governance. These are like 5-minute definition, and these are very good. And if you think that Sam needs to add more, try to contact him directly in LinkedIn or on Twitter, because he's asking, actually. He was recently asking what other technologies you want me to add. And he's very, very active and very collaborative. And we will have, actually, me and Brad will have later with him Twitter space. So this is another...
About 4 hours from now, we'll be on his Twitter space. You should definitely check that one out.
Yes. So CNCF Minutes is another good resource for quickly learning more about the CNCF landscape. Yeah. If I go back here, so you see that on the fundamentals, Kubernetes resources. So what do you think about Kubernetes resources? What do you think they mean when they say Kubernetes resources? If anybody started preparing for the exam, what do you think they mean by Kubernetes resources? We will not see the answers quickly. There was another question from Alyssa. Are the exam simulations available somewhere, or example of the exam question? Yes, that's what Andrew Brown in Udemy and some of his online friends have done. So if I go to Udemy, he has some practice question. This is not...
I believe Mohammed is going to have some practice questions in his repo. They're not quite there yet, but
yes,
just keep an eye out on that as well, because they'll be there soon as well.
I'm working on some practice questions here,
nice.
But they will be free also. They will not be, unless I can monetize them, that's fine then. So basically you can see that, he added actually. Last time I checked 2 days ago, it was 60, now it's 62. So I added 4 more questions. I guess if he breaks them into 4 sets, it would be better. So basically people can have quite a good feedback when they do 1 set, so that they know their weaknesses and stuff like this. So it looks like there is a discount going on for the next 5 hours. I am not sure who's targeted by this discount. So Marino with Jay from Solo, Samantha Jose, and Andrew Baiko and Andrew Brown created this practice test. And it's already rated high by 32 students, because it was just out last week. Yeah,
that's a good rating. Good rating so far.
Yes, I guess because it was out just last week, so there will be like typos or language issues and stuff like this. But the more students join, it will be all these issues will be weeded out. Okay. Any other questions? I haven't seen.
No more questions so far. No.
Okay. So let me go to the repo and give my opinion. So we talked about the cost. We talked basically Kathy Gamenji was one of the co-leads, and she did the test mostly. The other co-leads, like Chris, he collected SMEs, around 30 SMEs, asking what kind of subject and categories they need to add and some of the questions. But then Kathy basically took over and did most of the work. So the discount, we talked about it. My opinion that it's good to have a history and background. like about the OCI, the Open Container Initiative. Why did it come? Docker was very aggressive and was very changing because it was a very innovative, and the company was very innovative. So third party, they wanted to productionize, they wanted to run commercial workloads, and they couldn't keep up with Docker. So standard has to be developed. And if you understand the history, you'll understand where we are right now and why we have CRI-O, why we have Containerd, why we have the container runtime interface, and when do you need one versus the other. There is a keynote, less than 10 minutes, by the Dan Kohn. He passed away. He was the executive director for the CNCF, and he's very inspirational gentleman. He set some of the pillars for the CNCF, and it's good to watch and listen to his talks. I recommend this talk because in his talk, he will highlight certain things about CNCF. And if you understand these key points that he highlights in his talk, which I put them here in the cloud native definition, he emphasizes on declarative APIs. So you need to know what we mean by declarative versus imperative, because the whole Kubernetes ecosystem depends on the desired state. Unlike traditional systems, unlike traditional architecture, unlike traditional patterns. He also emphasizes on resiliency. So when we come back to the exam domains and we see Kubernetes resources and we see cloud native architecture, auto scaling, how can we? Where does the resiliency fit in these kind of topics? Okay. So for example, you know that there is a Kubernetes resource, the deployment, the replica set, the stateful set. How can you? What's their relation with resiliency? How do they differ from each other? What's the difference between stateful set and the deployment? When should I use a stateful set versus deployment? When should I use a daemon set? And all of them actually affect the scheduling part of it. Here you have scheduling, and for me, scheduling is a big thing. Scheduling for me affects auto scaling, affects the affinity, it's so many subjects. So if you know the fundamentals of cloud native and from its founders, okay, I'm guessing that you will figure out when you're studying for the exam or when you are actually pursuing a career on cloud native, and you keep this standard and keep these principles in your mind, I think they are very helpful. So the first question comes to mind: why Kubernetes? Okay, there is Nomad, there is ECS, there was a Swarm. Why Kubernetes? Why did it take the world by storm? Okay, so Kubernetes is a container orchestration system that can provide you resiliency, that can provide you reliability. How do you provide these? And how do you deliver the application and things like this? This is what the exam is all about. But as I said, it's at the lighter level, at the 10,000 feet, 20,000 feet. Sometimes they dive into the core concept. Sometimes, for example, you find a question about what specs, a certain technical specifications. Or sometimes they about a flag in a command line. So the command line, the most used command line, a kubectl. You can say it kubectl, kubectl, kubecontrol. Mm-hmm. But okay, you will not be examined on the pronunciation, but you will be examined on certain use cases. Okay, how can I run a deployment, or how can I create a deployment? How can I create a stateful set? How can I exec into a bot? How can I run a container? How can I exec a container? The generic use cases that you can find them in kubectl cheat sheet and Kubernetes.io documentation. Okay, and if you watch like there was an interview with Kathy, it's also less than 10 minutes, and she mentions this interview. She mentions basically the topics of the exam and stuff like this, and you can deduct from them what kind of topics you're going to be examined on and stuff like this, and how deep sometimes or how light. Okay. So my strategy that you need first to ask yourself, why do I need a certification? If it's for salary or job increase, or trying to find a job, according to Kate's Learning, According to some other surveys, it might help getting you into the door of HR, especially in big enterprises. Okay, most of the startup, most of the small to medium enterprises, they will give you like a use case that you have to implement within 2 days. So you need hands-on more than you need just an overview. Help. I mean, certification, I mean, people are divided. Why do I need certification? But if you are for the knowledge, if you are for the journey, I would say it's a good start to give you an overview of the ecosystem and where you need to dive in. I would start joining a CNCF community. There's so many meetups around the world. There's so many local and virtual events. I mean, we are still suffering from COVID, but as we are now, we have this virtual event. I mean, Brad is in Australia. I'm here working in Saudi Arabia, and look, we have people, I guess, from all over the world. So join a community, join Slack, and ask, and don't be shy. The community is very, very friendly and very supportive and very collaborative. Okay, you can start with learning the basics. You need the container basic. You cannot start Kubernetes without having an overview and knowledge about the container basics. And why containers? So the main reason was application portability. How does that happen? The democratization of the cloud and stuff like this. If you look at the documentary, the part 1, it talks a little bit about it. It doesn't say it clearly that they didn't have it in their mind, the democratization of the cloud, but that's what happened. That was the side effect when Kubernetes came out. And while you're studying, it's true that it's an introduction certification, but make sure that you emphasize on the best practices. If I'm building a container image, what are the best practices to build a container image? What kind of processes, what kind of practices that I should make sure that I follow? Okay, security from day 0, things like this. So non-running privileged users and keeping the image at minimal, stuff like that. And as we said, SIAM attack CNCF Minutes, the CNCF Glossary. Let's go to the CNCF Glossary cancel. So the CNCF Glossary, you'll find definitions and what does it mean, containerization, what is it, how it helps, what problem it addresses, things like this. And also, if I go to case.io, the important section in case.io, the Kubernetes documentation, if I go to the documentation section, make sure that you cover all the concepts. This is a free resource. Right? You don't need like a paid course to come over here. So if you go over these, if you go like, let's again focus on containers. Okay, so a container image. What is a container versus a container image? What are the container runtimes? And you follow the links and basically read about it and read the definitions. I think you will do very good. What is a runtime class? Why do I need it? What is so all these concepts, I think, are important for you to cover in the exam. This is what will give you the founding ground to know the definition, to know the basics, what problem they solve. Always make sure that what you have in your mind, what is it, what problem it solves, what is the use cases, what are the alternatives, how does it differ from the other alternatives. I think if you keep these in mind, I think you will do very well.
And I think just adding to that, when you go to do your other exams, KCAD, CKAD and CKA, you're allowed to look at the documentation. So the documentation is your friend. It's really comprehensive. They've done a great job. So one strategy I have is when I find something I'm looking for, I bookmark it, and then whenever I need to remember it again, I go and reference the documentation. It's a really good skill to learn when you do get in those hands-on labs where you really need, time is not on your side. So it's really good to start learning how to walk through the documentation as well.
So we have South Africa, Italy, India. The time zone is not really bad. We'll not have the Americas, but yeah, I mean, most of the world. Okay, so going back here, so if you focus on the Kubernetes fundamental, container orchestration, cloud native architecture, you guarantee your passing score. There will be like a little bit tricky questions, the questions that focus on the core components. I'm working on this, I'm not sure. Let me see. Okay, let's try to explain something. Is this visible enough? Or let me...
Yeah, let me go full screen. Maybe you might want to zoom in just a little bit more.
So the main object, the main resource, okay, everything in Kubernetes is an API, is an API endpoint. And when we say object, when we say resources, sometimes, most of the times we mean these resources, the pod, the replica set, the daemon set, the deployment, the cron job, and things like this. But sometimes we mean the compute resources or the storage resources, like how much CPU, how much memory, especially when we are talking scheduling. If we are talking resources and scheduling, we are talking specific. Does this node have a GPU? Does this node have a special function? Things like this. But when we talk resources in general, we talk about these kind of deployment, and you need to really cover these. You need to know, and especially the pod. If I were you, I would start, I would really cover the pod extensively. I know that I'm conflicting myself. I say don't go deep, but the pod is very important concept in Kubernetes. It is the smallest execution unit, and every other unit depends on the pod, and every other unit uses the pod definition within its definition. Okay, so how to create a pod? What kind of things inside the pod? Okay, so what's the difference between a pod and a job? And what is the difference between a cron job and a job? So if a cron job, if you are familiar with Linux, you know that I can run things periodically, and this is the same. So if I want to run things periodically within the Kubernetes cluster, within a specific time, within a specific date, things like this, maybe I can schedule a cron job. The cron job, at the end of the day, it will create a pod. So almost all the other deployments, at the end of the day, they will create a pod, except service. So basically, the pod will have an internal IP, and the pod is one container or more, and they share the network namespace. Okay, but the pod is ephemeral. By definition, we said resiliency. So how do I provide resiliency if this pod is ephemeral? Okay, I can use a replica set. Replica set means that instead of one pod, I will run two pods. And I might have probes like readiness probe, liveness probe, startup probe. And the function of this probe is to make sure that I know at what stage the pod is. Is it just starting up? Is it ready? Does it accept connections to it? If it accepts connection to it, I might create this object, the service, which basically is like an internal load balancer. And this one will have a static IP. This one will have a permanent IP that basically other services or other bots can connect to. And how do I know about this? How do I know about the service? Oh, there is a component called core DNS. It used to be called Kube DNS. It's core DNS. Is the one that is used right now. And this provides the service discovery. And you can see that I'm linking concepts together. If you can link the concepts together with each other, it would help in the long run. So what's the pod and what's the daemon set? When do I need the daemon set? So there are cases, especially in operations, especially in maintenance, like in monitoring, logging, security, where you might need a pod in every node or in most nodes. So that's the case where you need a daemon set. Can you have a daemon set in every managed Kubernetes on every Kubernetes? Not really, okay? But the exam doesn't talk to you about specific cases of managed Kubernetes. It talks to you in general. So in general, daemon set where you need a bot in every node. So this is a again, you can consider this as a special scheduling case because I want this bot in every node. Okay, so you can, it's not the scheduler. Actually, the scheduler will actually make sure that the bot will be running in each node. Okay, and what's the difference between deployment and replica set? Both they provide replicas, but why do I need a deployment? Oh, because I need to manage my deployment pattern. So the deployment strategy, I can run my application first in a few nodes or for a few users before I deploy it fully in everything, especially when I'm rolling a new version. Or I want to do what they call blue-green or black-red or black deployment or canary deployment. And what are the differences between these? Okay, stateful set. So when Kubernetes started, it was running stateless workload. But now there are some workloads that need a certain state. So what's the difference? When do I need stateful set versus deployment? Okay, so what's the difference between the names of the pods in the deployment and the stateful set? What's the difference between the service requirement in deployment and stateful set, and so on and so on? Okay, and what's the difference between service and ingress? So basically, both of these are ways to expose traffic, but service exposes traffic internally. Ingress exposes traffic at a higher layer, layer 7, the application layer, to the cluster. So I need to know, is ingress a service or it is not? No, it is not. Okay, so what is the specific and when should I use an ingress versus when should I use a service? The bot disruption budget, what does it mean? Why this object exists? What does it protect me from? And when I would come to scaling, I have the horizontal bot autoscaler, I have the vertical bot scaler, I have the cluster autoscaler, and I have other scalers like CADA, like based on events, things like that. And when it comes to storage, I can store things, for example, environment variable. I can store them in config maps. I can store them in a secret if it's sensitive data. Is the secret encrypted or not encrypted? Is it safe to save things in secret? What is a persistent volume claim? And all these objects, where do they live in the cluster? So there is a concept of namespace, which is a logical isolation. And if I want isolation, is namespace is enough? How about something called network policy, segregation at the network level and stuff like this? There's this gentleman, Ivan. This is his site, iximuz.com, and he produced several blogs and several diagrams that are very informative. I mean, I can learn from a visual diagram more than I can learn from a blog. And here he's talking about Kubernetes API, and you can see there are something called built-in resources, which is part of the upstream Kubernetes release. And there is, I cannot see. And there is the custom resources, which is how you extend the APIs. So, like for example, Red Hat distribution, Red Hat OpenShift, it's an enterprise Kubernetes distribution. But what they do, they use something called operator. So in the 5th domain of the exam, how to deliver Kubernetes application, how to deliver deployments, it covers Helm, it covers operators pattern, it covers the CI/CD, it covers GitOps. So to create an operator, basically you create a custom resource, and in this custom resource you capture the operator experience. Okay, now without so everything is very extensible in Kubernetes, and the custom resources allows you to do this. And it allows you to do it in something called API groups. So which command actually can show you which API groups you have, and which command can show you which resources you have, the object that we were talking about. So I said that kube control is important. And for example, if you do kube control API resources, you will see all the resources you have in your version of the cluster in your specific Kubernetes distribution. And you could also see the CRDs. You could also see the custom resources here. Okay, and so on and so on. And these are the endpoints for the object. Okay, any questions or?
We have one question. If you have, is it possible for the folks to see these slides or these visualizations?
Can we share URL? If we can share URL.
We'll just put us back on the screen as well.
how can I share the URL?
If you send it on the private chat, I can put it.
Okay.
I like the way that you did that as well. With it's a really good way of learning the high level, just how they relate to each other, and I think that's a great study guide.
Okay, when it comes to learning, I'm a little bit different. I am what you call neurodiverse, so I have some issues with the working memory, and it helps me if I can link things together. And this is a new product, actually. This is not general availability at mem.ai, and I think it's free for use now. I don't think they have pricing yet, or they have? I'm not sure. But it helps you link things together. So I started using it, and so basically it will help me. And it works like Kubernetes. So in Kubernetes, we have labels and annotations, and using labels, we can group things together, or we can find things, or we can create policies based on labels. So mem.ai works the same way. So the most of the slides, or apart from Ivan, this is from Ivan. Let's go to his website. I don't think I can. Yeah, Ivan. Okay. So this is Ivan. I shared them with you, Brad, if you can share them with the group.
Yeah, both of those links are now in the chat.
Yeah. Okay. So in Kubernetes Fundamentals, I think you should focus most of your work on Kubernetes Fundamentals and the container orchestration. I would start with the containers. What is basically container D, and things like this, and how to link them to the concept in architecture. If we go back to mem.ai, if I go back to an architecture of, I didn't put one. Maybe I should find one from the internet, or maybe from Case.io, Case.io, RT control. Okay, Kubernetes components. So this is a cluster. So a cluster is a group of nodes. The nodes that do the work, we call them worker nodes, and they have two components. That mean two components of a worker node is a kubelet and kproxy. What is missing in this diagram is that the kubelet runs containers, runs bots on the node. How does it run nodes? It interacts with the container runtime. So you could have a container runtime container D, you could have a container runtime cryo on the node, and the kubelet will interact with it and it will run. So it is missing here. The other thing that is missing is core DNS. You don't see DNS here, and it's used for service discovery. It's very important. Okay, but is it part of the control plane? I leave this as a question to you. And in the control plane, what you'll find the most important component. You see that there is a hub here. Everything is communicating with this hub. That's the Kube API server. Everything in Kubernetes is an API. All the objects are API resources. All the Kubernetes APIs, all the Kubernetes resources are actually API endpoints. So you have to have like a front end, like you have to have a front API server that is responsible for authorization, for authentication, responsible for delegating tasks and stuff like this. So for example, if I want to schedule a bot, somebody will run kube control, let's say create deployment, and the deployment will create bots, but the bots cannot be scheduled yet. They will be like a non-ready state yet. They will be vending. So the scheduler will check with the API server, with the what happens actually, most of these components in the control plane are stateless. The only thing that is stateful on Kubernetes control plane is the etcd. So if a user communicates with the API server via kubecontrol or via other tool, via CI/CD or GitOps or whatever tool, okay, the API server will resist the state of the request on etcd, and the scheduler will check with the API server, does etcd have a new deployment or a new requirements? And if there is a bot that is not scheduled, and what does it mean unscheduled? That it means that it doesn't have on its spec node name, let's say. That's how the scheduler looks for non-scheduled bots. So it will run its algorithms and try to find the best node that fits the bot requirement. Yeah, so what I'm trying to present here, I'm trying to present the architecture that you have a control plane. And the control plane, the main core component is the Kube API server. There's the scheduler. The scheduler responsibility is assigning bots to nodes. And there is something called the controller manager. The controller manager is like the replica set, like the deployment, like the node manager. These are responsible for monitoring the state and making sure that the cluster is in the desired state. There is like something called, there is a control loop running all the time, simple control loop. If I said I want Nginx, 2 replicas of Nginx, how can Kubernetes make sure? Because basically the deployment has a deployment controller that looks, the deployment actually creates a replica set, and the replica set controllers keeps an eye on the specs, and the spec says I need 2 bots. So if there is less than 2 bots, it will make sure it will create a bot. If there is more than 2 bots, it makes sure that it will delete 1 bot, and so on and so on. Now, can I have a kubelet in the control plane nodes? Maybe yes, maybe no. Most likely yes. Why? Because there is something called static bots. How do I run these things? How do I run actually? Now, everything in Kubernetes is actually bots. There are different Kubernetes distributions which these services, the control plane services, the control plane components are run as systemd units. But most of the Kubernetes distribution now, they run these as static bots. So what does it mean, a static bot? A static bot is created, but not through the API server. It's created using the kubelet. So I need to have a kubelet in the control plane. So what's the difference between a static bot and a normal bot? This could be another question. I'm just anticipating. I don't really know. Okay, so this is a good article here. Okay, and it's again under concepts. So you see concepts, Kubernetes components, and that will cover the architectural part of the exam. Any questions?
Please, anyone, if you have any questions, let us know. We don't have any so far.
Okay. Let's check Muhammad Abu Bakr is GitHub. So basically the same things. Okay, he points to the official KCNA curriculum, and it's useful because every 3 to 6 months for the other exams, the Kubernetes release matters. I think for this exam, it's quite stable. It doesn't really matter much on the Kubernetes release, except, for example, now we will not see much about Docker because the Docker scheme is removed. And some of the architecture diagram, they still refer to Docker as the container runtime and things like this. He puts the most acronyms and keys here. So KATES, this is how we abbreviate Kubernetes. So we count the 8 letters here, and the 8 letters, we replace them with the KATES. Observability is also the same. We put O and then 11 characters and then Y at the end. So we abbreviate observability by O11Y. What does it mean? The CNCF, the Cloud Native Computing Foundation, NetBol, the network policy, they are an important object. They are the one that provides isolation in the cluster. By default, the cluster, every bot can communicate with another bot without NAT. But if you want isolation, you can do isolation on the namespace level or basically based on the bots using net policy. The persistent volume and persistent volume claims, this is how you provide storage to your applications. There are different types, and how to integrate backend storage with Kubernetes. You have to have something that is CSI compatible nowadays, which is the container storage interface. You can connect to NetApp, you can connect to NFS, you can connect to object storage like S3, or S3 compliant like MinIO and Rook. The Rook operator gives you more than one type of storage. You have the CNI, the container network interface. So there are different container plugins. For example, AWS has its own AWS VPC CNI. There are two very popular network CNIs, the Calico and the coming one, Cilium, which is an eBPF using eBPF. It's growing, and we will see more of it this year, hopefully. What is CI/CD when it comes to application deployment, application delivery? It's a very important concept in DevOps and on cloud native. And this is how you should deliver your application in an autonomous and non-manual way. The role-based access control, again, role-based access control and network policy is two mechanisms where you provide security. So role-based access control is a granular way where you can define actors like subjects, and what kind of subject you can have. You can have a service account, you can have a user, or you can have a group. And this subject, you can say he's allowed to run certain verbs. And these verbs basically map to the HTTP verbs like get, delete, put. And there are two extra verbs like list, and I forgot the other one that specify certain actions against the resources. What kind of resources? Secrets, bots, deployments, you name it. The OCI, the Open Container Initiative, that have given rise to the CRI, the Container Runtime Interface. So the CRI describes how you store a container and how you run it. The CRI basically allows you to run different container runtimes in Kubernetes. The SMI is a service mesh interface standard. Service level objective and service level indicator and SLAs are part of an SRE culture. This is how part of the observability. So when you have observability in your organization, usually an SRE is responsible for talking to customer and creating the service level objectives, service level indicators, and service level agreements, and monitoring them and making sure that the service is reliable. Okay, so the most important thing in the Kubernetes fundamentals is the concept of bots. And I think when it comes to bots, I would really like you to dive deep in the bot concept. The best resource for bots is the book Kubernetes Up and Running from Joe Beda and Kelsey Hightower. And the first chapter is like the most important chapter, which talks about bots all the way. And I think that you will do really good in general in CKA, CKD, whatever, if you understand the bot concept very carefully. And the bot object, because every other object is based on bots. He has clarification, bots in Kubernetes, deployment in Kubernetes, services in Kubernetes, replica set, okay. Now, replica set, you don't see a replica set created by a user. Usually, replica set gets created by deployment. Okay. Now, you might find some sites that will create replica sets, but usually you shouldn't really create a replica set. It should be created by the deployment. He talks about a headless service. So services, headless service is one of 4 types of services. So a service you have by default something called cluster IP, which is like an internal, here he describes it, like an internal IP within the cluster. And then you have a node IP, where you expose a board in the node, and it will be a static board, and it's not really good with security practice. And then you have a load balancer, which needs a cloud manager to work. or it needs an extra component to make it work if you are on-prem. And there is a headless server, which is a requirement in certain Kubernetes implementation, like in the stateful set. Like in Kafka, for example, where basically a certain service is specific to a certain bot. Here, the Kubernetes architecture, he has the API server. I would have put it here. And then, but okay, because the API server talks to the other control plane components, talks to the scheduler, talks to etcd, talks to control manager. So if I ask you what is missing here, is usually the cloud manager. Most people, they don't put it because in a cloud, even if you're running in public and private cloud like vSphere, it does have a cloud manager to manage the storage. And sometimes it manages the storage and manages the load balancer. But I see lots of Kubernetes architecture diagram. They are usually missing the cloud manager. And now in the control plane, this is like just for illustrating diagram. Usually you should have more. You will not have one control plane node for high availability, for resiliency. It's recommended that you have at least 3 for etcd. This is the minimum and good number for replication for etcd. Okay. And what's the difference between active and passive, for example, for something like the scheduler? The scheduler is a replaceable component. Like, for example, if you are using Portworx storage, they will use their own scheduler for scheduling storage workloads to nodes, because they know exactly the topology of your cluster when it comes to storage, better than the default scheduler. And there are other schedulers also. In the CKA, actually, it was one of the objectives, if you can run 2 schedulers at the same time or not, and when can you do it, and how you do it. So Kubernetes going to reference, nodes and K8s. So the node is the abstraction of a physical server or a virtual server, or even a KubeVirt object, actually. Correct, Brad? You can have a logical node, and that's, I think, how Netflix is running some of their services. There is lots of communications. If I go back here, there's lots of communications happening in. Yes, so this is, I like this. This is from Weaveworks. And so you have here the control plane, the control manager, the API server, the scheduler, the etcd, and you have a worker node. And here you can see the kubelet is the point of contact between the worker node and the master node. We are like 8 minutes over the hour. Is that fine?
Yeah, it's fine. Yeah, this is really, really good. I think people are going to really benefit from this.
Okay. So what I'm trying to say here, that Kubernetes is not easy. It's quite, there's lots, I mean, you can dive deep into many things. You can dive deep into storage, you can dive deep into networking, you can dive deep into architecture, into application development and deployment. Whatever subject you want to dive deep, you can dive deep. But in this certificate, you don't need to dive deep. You just need to know the components, and you just need to know the standards. So here, the kubelet is is on the node, is part of the node, and it interacts with container runtime. How it interacts with container runtime? Using container runtime interface. So it uses the standard container runtime interface. The container runtime, we said it could be container D, it could be CRI-O, it could be gvisor, whatever. And the other thing we see here, networking. So kubelet also works with the node networking through CNI, through the Container Network Interface Standard. So the Container Network Interface Standard, we said there are many plugins, like the Flannel, like Calico, like AWS VPC CNI, like Cilium. There is so many, like OVN Kubernetes, OpenShift SDN. There are so many. Okay, why do you need one over the other? And sometimes you can chain them to each other. Sometimes you can chain Calico, for example, to AWS VPC and so on. But all you need to know that kubelet is like, it has a pluggable model. It doesn't do networking straight with the node. No, it talks to the CNI to do the networking. It talks to the container runtime to know the state of the container is running and to know and to create a new container. Now, but the Kubernetes doesn't really work with containers. It works with pods. But the kubelet will know basically this pod is this container and will work with the container runtime to make sure that they are running, or to report the state back to the API server. And the API server reports state back to the etcd. And the other components can check through the API server. They cannot check with etcd directly. They check with the API server. What's the state of the replica? What's the state of the deployment? What's the state of the service, the endpoints, and all the stuff? Yes. And at that note, if there's no questions, maybe we should close today's presentation and hope the best for our brother Muhammad next time. But we need your questions. I haven't seen questions on Slack. I haven't seen questions on the LinkedIn invitation or in Twitter. I mean, if you give us questions, you can direct us what we can cover, or we can create slides and basically present. We need your questions. So that how would you like? What would you like to see in this forum for the next sessions?
Yeah, please reach out to us. And yeah, I think this was probably one of the best sessions I've ever seen. So yeah, thanks so much on the behalf of everyone. It was really comprehensive, and I think it's going to help folks a lot.
Thank you, Brad. I mean, I was telling Brad that yesterday I had a very hectic day. Two of my colleagues had one had positive case, and one was like asymptomatic. And I thought that I had COVID yesterday, but I did the test and it was negative, so everything is good.
That's good.
And stay safe. I mean, it's really the situation here is getting very dire. The numbers are increasing. And everyone I talk to, basically, it's the same everywhere. In India, in UK, I mean, everyone I talk to, it's the same. So stay safe, stay indoors, and take the precautions. Wear your masks and whatever. Yeah, stay distance and whatever. Work remotely. I mean, we are working not remotely, but you work remotely.
Okay.
And join the community.
Yeah, join the community. It's amazing though, all the resources we've seen so far. Like the exams only just come out, and the community has done so well at preparing these resources to help everyone. It was really good.
Yes.
Really good to see. Yeah, and thanks everyone for engaging in the chat. It's always really cool to present when we have lots of questions and engagement.
So we promised that we will give 3 giveaways. One was for Alicia, and somebody else asked a question, so I guess we have 2.
Yeah, we had Annalisa, and Clive was quite active as well.
Okay, so basically, please get in touch with us.
Yeah. Thank you so much for providing them as well. That was really nice. I think it was Andrew Brown you were saying.
Yeah, Andrew. Yes.
Yeah. Okay. Yeah. All right. Well, yeah. Thank you so much. And if anyone needs to reach out to Waleed, you can see his Twitter handle on the screen as well. So yeah, reach out if you have any questions. And yeah, thank you so much for coming today. It was really amazing to see.
Thank you, Brad.
Yeah.
Thank you, everyone.
All right. And thank you, everyone. We'll see you soon. Cheers.